Hi, this is Phil from Simply Rhino, and in this video I'm going to look at creating this laminated plastic protein pouch in Rhino. I'll start by creating a dimensionally correct model that can be used for production and artwork, and then go on to look at adding some irregularity to the model in order to create a realistic visual. I'll be using a SubD workflow which, whilst being fairly simple, requires an understanding of maintaining a simple four-sided topology. This allows for the creation of a dimensionally correct rigid version of the pack that can then be easily deformed for visualization, meaning that both production data and visuals are derived from the same model. The starting point for the model is going to be this guide that I've created with polylines. The rectangle describes the overall width and height of the pouch, and this polyline describes the side profile structure. There are, of course, many ways to construct this model, but I'm going to start by creating the side profile shape. I've created a few layers already, so I'll make the curve layer active and create a new control point curve, making sure the SubD friendly option is set. In simple terms, using a SubD friendly curve will ensure that the precise shape of the curve will be maintained when building a SubD surface from it. I'll start the curve by snapping to the start of the polyline and then to the midpoint of this first section and then to the end. I'm going to go to the midpoint again here and then to the end, and the next point is going to be roughly equidistant from the midpoint above, and then one more point here, and finally a point at the end of the polyline. To tighten up this corner, I can turn on the control points and move these points closer together, and in order to equalize the topology, I might want to push this point a small amount vertically. Open SubD friendly curves have grayed out control points at the second and penultimate positions. These points maintain a geometric limitation of zero curvature, or infinite radius if you prefer, at each end of the curve. In this case, however, the implications of this are not especially important. However, both SubD and NURBS topology are covered in detail in our Simply Rhino Level 2 course. Working in a maximized perspective viewport, I'll go to the SubD menu and run Extrude Curve Straight. I'll pick the curve and enable the Both Sides option. Then I can pull out the extrusion surface and snap to the blue rectangle in the guide layer. I'll then copy this surface onto the offset layer. From the SubD toolbar, I'll run Offset and offset outwards by a distance of 0.5 mm, which represents the thickness of the heat-sealed edges of the pouch. The offset direction indicators are pointing inwards at this moment, so I'll choose the flip option to change the offset direction. When working with SubD surfaces or solids, these can be visualized in either the smooth mode or the box mode. The smooth mode is the limit surface or the smooth SubD surface, and by hitting the Tab key I can enable the box mode or control net that shows the polygon structure of the underlying SubD mesh topology. Using the box mode will make the editing of the next step much easier. I'll run Duplicate Layer and Objects and rename the resulting layer Delete Faces. I'd like to create a new layer for each of the major stages in a model, as this allows me to retrace my steps if I change the approach or design later on. I'm now going to delete some SubD faces, and I'll use the Extract Surface with a copy option on to extract these two faces and then enter and delete. I've now created an opening in what was a closed SubD, and because the offset has creased edges, then this opening will be rectilinear in both boxy and smooth modes. I'll run Duplicate Layer and Objects again, and this time rename the layer Mirror and Join, and of course that's going to be the next step. I've set my geometry about a line of symmetry so I can pick this half of the pack, and in the mirror command I can use the x-axis prompt for this with the copy option on. Next, I can select the two SubDs that will now have coincident open edges and join them together. Switching to the smooth display mode shows the expected result. I've now copied the geometry onto another layer which I've named Insert Edge, and switch back to the box SubD display mode. Before modifying the geometry, I'll add symmetry via the reflection command. This allows one half of the model to update automatically, mirroring any changes on the live half. So I'll run reflection from the SubD toolbar, pick the SubD object, and then choose the Y-axis option. In the preview, I'll see the symmetry plane and be able to flip which side is the live side. Once completed, the reflected side previews as dark grey. Next, I'll insert an edge that will define the extent of the heat-sealed edge of the pouch. So I'll run Insert Edge from the SubD toolbar using the Range option and start to pick this edge. And this is what will effectively be copied and then moved to create the new edge. Double-clicking here will pick continuous edges, and once I've selected the necessary edges, I'll choose the absolute offset mode and input a value of 10. The new edge will now be inserted, and the reflection command will mirror this change on the other half of the geometry. Next, I'm going to add a similar condition on the bottom edge, and at this stage it's important to concentrate on the topology and maintaining a simple four-sided structure using the simple premise that if the topology is right, then the shape will pretty much look after itself. Now, of course, that is an oversimplified statement, but nevertheless it's the topology that is driving the shape. I'll use Insert Edge again using the same parameters as previous and pick these bottom edges, which will result in new edges here and a four-sided face in the corner. When I switch to the smooth SubD display mode, these new edges will move inwards, but I can control the position of these absolutely in the next few steps. Next, I'm going to extract the faces inside of the 10mm boundary I created with the inserted edges. So I'll use the same extract surface command I used previously to remove the 10 interior faces. For the next step, I want to close off the sides and base of the pouch inside the 10mm boundary, and I'll do this on a new layer called Bridge. There's a number of methods to close off these openings, but I'll look first at the Bridge command. The Bridge command is here, and I'll make sure I have the Edges rather than Edge Loop option enabled, and I can then pick the 3 edges on this side and enter before picking the corresponding edges on the opposite side and pressing enter again. I'll then see a preview of the newly created faces, and for now I just want one segment, which will create 3 four-sided faces from the 3 pairs of picked edges, and I'll check the Join and Crease options. Next, I'll look at closing off the top of the sides, and, working on a new layer, I'll run the Append Face command from the SubD toolbar. This command allows for the creation of faces with a predetermined number of sides that will attach themselves to the chosen SubD object. It's also a useful command when making topology changes involving adding and removing faces. I'll run Append Face and pick the SubD pack. Then from the command line options I'll choose Quad and Multiple Faces. I'll make sure that I have the Vertex Object Snap on and maybe turn off the Point Snap. I'll now snap to the 4 vertices, and this will create a new face appended to the SubD pouch. Next, with the command still running, I'll change the polygon type option to triangle and append the upper face, again by snapping to vertices. I'm going to add a crease here to these edges, and this needs to be a hard crease. So I'll right click on the crease icon here, pick these 4 edges, and that has added the hard crease. And this is recognizable in the box mode by the thicker edge display. Everything is now closed up apart from the bottom. And before closing this up, I'll remove the symmetry from the SubD by right-clicking on the reflection icon and then picking the pouch. To close the underside, I can either use the Fill Hole command or Append Face. So I'll go with Append Face, make sure the polygon option is set to quad, and snap to the 4 edges here. Once finished, I'll add a hard crease to the 4 edges as previous. Looking at this with the SubD display set to smooth, I can see the sharp defined structure is maintained with only the shoulder area here having some curvature. The main elements of the pack are done now, and I just need to add a little more detail and definition. Next, I'm going to add some edges to control the outer face of the heat-sealed perimeter, and the first step here is to add a reflection, and I'll set this about the y-axis. I can then run Insert Edge, and I'll select all the outside edges, including the 2 small ones across the top. I'll hit Enter, pull the cursor towards the center of the pack, and set a distance of 10 using the absolute option as previous. I'll repeat this process on the bottom of the outside edges, making sure not to forget these small edges here and the corresponding ones on the underside. So that I can push the center of the sides inwards later on, I'll insert another edge in the middle and pick these 4 edges here, and then come along and snap to the midpoint. Looking at the resulting topology at the top of the sides, I'll now have a 5-sided face here, and as I want to add a crease on the underside of the heat-sealed edge here, it would really help to simplify the topology by dividing both of these surfaces along the middle. Insert Edge isn't going to work in this instance, but instead I can use the Insert Point command. So I'll create another layer and then run Insert Point from here. I'll then pick the SubD and snap first from vertex to mid, and then up to the vertex here. This will divide these 2 faces vertically, and I can now safely put a hard crease on this inside top edge here. Switching to the smooth SubD display mode, I can see that this top area is now looking correct. I need to add an additional edge across the underside, as I neglected to do this earlier. So I'm going to remove the reflection, and then I can use Insert Edge to copy the 2 edges here to the midpoint of this perpendicular edge. Then I can use Insert Point for these smaller edges here, making sure I'm using the vertex and mid snaps. One of the nice things about SubD is that there's always an opportunity to add and remove faces and edges to change or improve things as the design progresses. Next, I'll add the rounded corners to the heat-sealed boundary, and I'll first reinstate the y-axis reflection. I'll use the bevel command, which is a sort of fillet edge equivalent for SubD, in that the starting point is a sharp edge. Unlike fillet edge, however, it isn't possible to specify a constant radius, as the resulting smooth SubD is going to behave like a degree 3 NURBS surface. I'll look at the bottom first and pick these 2 edges. I'll run the bevel command and set the segments option to 6, and then pull outwards, and the extent of the bevel will be constrained by the next edge along. I can then repeat the process on the top corner, taking care to pick the 2 edges that are involved here. Once again, the next edge along will constrain the size of the bevel. Finally, I'll look at adding a small bevel on this edge here, and I'll aim for something that looks like approximately 3 to 4 millimeters. There's no edge to constrain the bevel here, and depending on the active snaps and mouse movement, it can be quite hard to constrain the bevel accordingly. I'll now look at the result with the smooth SubD display mode, and the geometry looks complete now. So if I need to create artwork or dimension drawings to aid manufacture, then this is a good reference. For visualization, however, I now need to add some irregularity to the pack to make it appear more realistic. Working on a new layer, I'm going to start to add the irregularity, and I'm going to do this in two distinct stages, starting first by moving edges and faces on a copy of the existing model. Working in the SubD box display, I'll limit the selection to edges, turn on the gumball, and move a few edges at a time, making sure to check the result after each movement by toggling to the smooth SubD display mode. I'll need to be especially careful when moving edges and faces inwards, particularly when working close to the sides of the pack, to make sure that I don't push the outside of the pack through the inside edges. And I'll also work without symmetry as I'm looking for an asymmetrical result. I can also work with vertices, as these are sometimes easier to control, and depending on which elements I'm moving, I'll need to constrain the gumball movement accordingly. Gradually, by push-pulling faces, edges and points, I'll arrive at a result that is starting to look more realistic. To enhance this result further, I'm going to look at subdividing the complete SubD form. So I'll duplicate the layer and objects and rename the new layer Subdivide. When I run the Subdivide command from here, each four-sided face will be subdivided into four by adding one edge in each of the two face directions. Subdividing the complete model shouldn't change the overall shape in any meaningful way, and to check this, I can change the layer color of my Subdivide layer and turn on the previous layer for comparison. I'll do another round of nudging faces and edges on the subdivided form to add more undulation and some soft depressions into the shoulder area. Subdividing generally like this is fine for the four-sided faces, but it can adversely affect the topology of more complex areas, like, for example, the inside of these rounded corners. So I'll carefully remove edges on areas like these to simplify the face structure. Next, I'll look at creating a quick visual, and one of the first and perhaps most challenging tasks here will be to create and apply a material. I have full-size artwork here for both versions of the pack, and this is a simple black and white artwork that has the usual crop and bleed marks. I've put in some extra registration marks that define the shoulder area, and the artwork is presented in a square format. This is important, as can be seen shortly. I've got two versions of the artwork, and these have exactly the same registration, meaning that I can easily make the second material variant. I'll save this out as JPG or PNG images, being careful about the size of these images. They only need to have an approximate pixel density for the render size I'm going to produce. Back in Rhino, I'll switch to the rendered display mode and create a new physically based material. In detailed settings and base color, I'll apply the artwork material I just created by clicking on the checkerboard icon and navigating to the bitmap image file. The material will update in the rendered viewport, but the mapping, i.e. the placement of the artwork on the model, will appear arbitrary at this stage. I'll look at the metallic and glossy values of the material later on, but for now I need to concentrate on the positioning of the material accurately on the model. I don't need to pull the model apart to do the next step, as I can use Unwrap to separate out the various faces of the pack into what McNeil calls islands, and then use the UV editor to place these islands on the artwork. I'll pick the SubD and run Unwrap, and accept the default mapping channel 1 and enter. At the Select Seams prompt, I'm going to start selecting the seams that will separate out the various faces or islands. So essentially, the front, back, left, right and bottom. This requires some careful picking and also, of course, a model that has an appropriate structure to do this. I've included the inside edges of the heat-sealed seams in the left and right sides and bottom, and the thin outside edges of those seams in the front and back islands, meaning that I'll have 5 islands in total with some slightly irregular boundaries. So now I'll finish the selection by hitting enter. Now I can open the UV editor and I'll see the flat artwork and the 5 flattened mesh islands. The metaphor here is that the artwork stays at a fixed size and the mesh islands can be scaled, rotated or adjusted to fit the static artwork. It's possible to see which mesh island relates to which part of the model by clicking on the part in the UV editor. I'll switch to the rendered viewport, find the island that represents the front face, and then move the other islands out of the way. Then I can position and scale the front island to the artwork, gradually scaling and moving until this looks correct. Then it's just a case of repeating the same process for the other islands. There isn't a specific artwork for the bottom, but on the understanding that this is going to be black, I can just reduce the scale of this bottom island and drop it over a black area of the front artwork. This mapping will be saved in the UV editor, so I can close and open the editor again should there be a need to make any changes later on in the process. Back in the rendered viewport, I can make some changes to the reflective environment and background, and then open up the material and move the metallic slider to the right, and also add a clear coat value to make the pack material more like a laminated or capped plastic sheet. At this stage, it's perhaps best to check the result in the ray traced viewport, as this will create physically correct reflections. For the composite view here, I've copied the pack into a new file and duplicated it across 3 new layers. The material and mapping will of course copy with the SubD geometry, and I can create the silver clean energy material by simply duplicating the dark energy material and swapping out the bitmap texture. It's likely that the metallic and reflective values will need to be reduced on the silver pack to prevent the highlights from blowing out. I can then render the image to the appropriate size. I'll choose the EXR format if I need a high bit depth image for adjusting in post, and finally there's a process that I can use which will make it easier to mask the packs in an image editor, allowing them to be edited independently of the background and each other. Working on a copy of the file, I'll create 2 new emissive materials, one of which will be 100% red, so in RGB terms 25500, and the other 100% blue, so 00255, and then replace the dark energy material with the red emissive and the clear energy material with blue emissive. Then in the rendering tab, I'll set the background to black and uncheck Use Custom Environment for Reflections, which effectively turns off the reflections. I'll then uncheck Use Custom Environment for Skylighting. I'll now have an effectively unlit scene with 2 emissive materials that will render out as a flat red, blue and black masks. If I then bring this into an image editor as a separate layer, I can use this to create simple selections using the magic wand or equivalent, which allow me to adjust, for example, the exposure, highlight, shadows and saturation of just the selected packs without affecting the rest of the image. So that's about all I wanted to cover in this video. Thanks for watching, and please feel free to leave any comments below. If you found this video useful, then please hit the like button, and remember that to keep up with the latest developments in Rhino, you can subscribe to this channel. At Simply Rhino, we offer training for Rhino and all its key plugins, so check out our website for more details. Thanks again for watching, and I'll catch up with you in the next video.